Today we're going to talk about angles in a circle. And I put a little note there, yes, we are going to have a quiz on Monday. So we have three situations that can occur when we're making angles in a circle. So we need three circles. You always have to put a center in your circle, so I'm going to put a dot in each one to show, okay, this is the center. So we need two lines to create an angle. Well, we can either have two lines where they hit exactly on the edge of the circle, so the vertex of the angle is on the edge of the circle. We can have two lines that just end up crossing inside the circle. We could have two lines that end up meeting outside the circle. And with all three cases, they form an angle. Well, there's a relation between the angle there and the arc that goes with those lines. So in our first case, the arc on the circle would be this that I'm highlighting in blue. Let's call it arc AB. So this situation is called an inscribed angle. And there's a relationship between arc AB and angle theta. Angle theta is half of arc AB. It's half the size angle-wise as our arc measure would be measured in degrees. So we could also maybe know the arc. I'm saying this backwards. Maybe we want to find the arc measure and we're given the angle, so we could say this kind of backwards. We could also say the arc is twice the length of the angle. So for example, if arc AB was 100 degrees, I would use my first formula. I'd say, well, theta is half of that, so theta is 50 degrees. Or if I knew theta was 27 degrees, and I wanted to find the arc, I could say to multiply that by 2. Arc AB would be 54 degrees. On our second situation, because we have two lines crossing, we end up with two arcs. We still have arc AB and then arc CD. And it has a little bit different relationship. This one, the angle, theta, is half the sum of the arcs. Or in other words, half arc CD plus arc AB. Notice that our equations do have something in common. Our first equation started with a half. Our second equation starts with 1/2. Our third one will also start with 1/2. Again, we should highlight the arcs we're using. We have arc on our top, we call that AB. On our bottom, CD. So all of our other equations had half involved. This one will as well. And this time, instead of being the sum of the arcs, it's going to be the difference of the arcs. Now mathematically, think about what difference means. Difference is subtraction mathematically. So when we're doing this, we must always do the bigger arc minus the smaller arc. So on our two arcs, arc CD is definitely larger in size than AB. So arc CD minus arc AB. Or sometimes I write big minus small, just so I remember, hey, I should start with the big arc minus the small arc. So those three angle formulas are what we're going to use to find different angles with these situations of having lines crossed inside or outside a circle. So here's our first example. It wants us to find the measure of the angle. Now there's a question mark inside. I do that because on the assignment, the program I used places a question mark there automatically. But really, that's just theta. Instead of a question mark, I'm going to put the theta symbol. And something I always like to do when I'm working with problems like this is highlight the angle I'm working with and the arc I'm working with. Just so I know, what do I need to focus on? I need to focus on the black angle and the red arc. Those two are related to each other. Then we have to think back to our three situations. Is this an inscribed angle? Did we have two lines cross and meet somewhere in the middle of the circle? Or do we have two lines meeting outside the circle? This is our first situation. This is an inscribed angle. So if we could find the red arc, then we could find theta. Those are related to each other. We would just divide the red arc by 2. But all they gave us was this 80 degrees. Well, if you think about what they've given us and what we're looking for, the green arc and the red arc together, they form an entire semicircle. They're half the circle. And we know how many degrees are in half a circle. There's 180 degrees in half a circle. So if I did 180 minus 80, I'd get my red arc, which is 100 degrees. Then I can use my information. We know this was inscribed. We know theta is 1/2 the arc. 1/2 times the arc. So we substitute now. We know the arc measure is 100 degrees. 1/2 times 100 degrees is 50 degrees. So let's do a second example. Dang it. My tablet had disconnected, so I thought I had to re-record the video, but it looks like we're good to go. So let's move on to example 2. So example 2, making it a little more complicated, we want to solve for x. Now we have to decide what situation do we have again. Do we have the angle on the outside edge of the circle? Do we have two lines crossing in the middle? Or do we have two lines outside? And of course we have two lines crossing in the middle. So we're going to use the formula theta equals 1/2 times the big arc plus the small arc. And again, I want to highlight kind of what lines are we working with, what angles are we working with, what arcs are we working with. So the lines that form the angle 140 are those two lines. The arcs that go with those two lines are on the left and the right. So again, we're going to plug stuff in. This time we're trying to solve for x though. So once we plug stuff in, we're going to have an equation we have to solve using algebra. So first, everywhere I see theta, I'm going to replace with the angle, 140. So instead of writing theta, we write 140 equals 1/2 the big arc. Now, to me, it looks like the green arc is bigger. So we're going to have 3x minus 5 first. We're replacing that for the big arc plus the small arc, 5x. So now we have an equation we just need to solve with algebra. First, we combine like terms. Inside the parentheses, 3x plus 5x, we would combine first, which is 8x. Now usually at this point we would add the 5 to both sides, except it's inside parentheses. We can't just add it over. So I need to do something with that 1/2, so that when I get rid of the 1/2, the parentheses will go away. Well, that's 1 divided by 2. We know the opposite of division is multiplication. So we're going to times both sides by 2 to get rid of the 1/2. But what we do to one side, we have to do to the other. So the 140 had to multiply by the 2. And And that helps get rid of the parentheses. So now we just finish solving this equation. It's just a normal equation that we're used to now. We have 5 to both sides. Get 285. Divide both sides by 8. 285 divided by 8 is 35.6. So we just have one last example. Obviously we've done the inscribed angle, we've done the angles where the lines cross inside, and now we're going to work with angles where the lines cross outside. So we're going to be using our third set of equations. Again, we're trying to solve for x. Notice all of them have x now. So again, I'm going to start by highlighting my various arcs and the lines used. So my lines are outside the circle, and the lines are what create the angle, so we know 3x plus 4, that's theta. The arc is where my lines hit the circle. So there's one arc, and then the other arc is the rest of the circle. So again, we set up an equation that we can solve. This time it's theta equals 1/2 times the big arc minus the small arc. We've already said, well, the two lines that are touching, that's where theta is. So theta is 3x plus 4. The big arc is 7x minus 8. Minus the small arc, 2x. So there's our equation that we would use to solve for x. I want you to finish solving this equation as part of your notes. I'm not going to do it together, but I will show you the answer so you know if you're doing it correctly or not. And I will check it off as part of your notes tomorrow. You won't get full points unless you show me the work for solving this equation. Tomorrow, I mean Monday. So don't forget, we will have a quiz on Monday when I see you next.